Hello, this is Armin. I am a CA of CS113 for spring semester 2025. Today I'm going to be going over practice final exam number 2 just to help you guys prepare for the upcoming finals. So we'll get started with some multiple choice questions, then do some open-ended at the end. Let's jump into it. The first question we're looking at, so questions 1 and 2 below use the following partial class definitions. So question 1 is asking which of the following is true with respect to C1, C2, C3. So we're looking at super and subclasses. So let's analyze the classes we were given. You can see we're given public class C1, public class C2 which extends C1, and public class C3 which extends C2. So going through the inheritance, we can say C1 is our most super class because everything extends from it. So this is our super class. So then C2 extends C1. So C2 is a subclass C1, or you also call it a child. We see C3 extends C2, so C3 is in a subclass or a child of C2, and we get that from the extends keyword. So which of the following is true? C3 is a superclass of C2. That is incorrect. It's the other way around. C2 is a superclass of C3. And then they switch it for the next part, so that makes no sense. B, C1 and C2 are both subclasses of C3. That's incorrect because they don't extend C3. C1 and C3 are both subclasses of C1. Now this is tricky. This is incorrect. Technically this is incorrect because C3 is not a direct subclass. It's more of a grandchild, you can say, because C3 extends C2, which extends C1. So yes, C3 is a grandchild of C1. It's not a direct subclass. Then D, C3 is a subclass of C2, that's correct. C2 is a subclass of C1, correct. So D is our correct answer. C is technically right, the wording is just what makes it wrong. And number 2, which of the following lists of instance data are accessible in class C2? So, what instance data can we see and use in C2? So first are easy, X and Y. X and Y, because they're in C2. But we extend C1, so we inherit a lot from there. And we always inherit everything that's not private. Private is something that's only in that class. So B is only part of C1. A and C, however, are public and protected. Public meaning anyone in or out of the class can access it. Protected being only the current class and all child, grandchild, etc. classes. We would also see A, and we would see C. So X, Y, A, and C is our answer, C. All right, number 3. In the following array, what is the value of stats dot length? So we see stats is a 2D array of doubles. So we have the double, which is the type. And then we have one set of brackets, two set of brackets. So it's a 2D array. Then we see, right, we have our first level of braces, That's declaring our first dimension, and then we have object 1, object 2, object 3. So we say stats is an array filled with 3 arrays. So the length of stats.length, the length of how many elements are in, how many arrays we have in our stats array would be 3. So we have 3 elements. So none of the above. Okay, given the class below, what is the output of the following program execution? So we're given an exception, which is a basic exception on the left. We have class post number exception, extends exception, and then we have our classic constructor, which takes in the message and then gives it to our super constructor, or the constructor in exception. So if we look at the code on the right now, we have a class tester as a driver program. We have our main method. We have a array of numbers, or string representation of numbers. We have 4 of them. We create a new problem, which is of type post number exception, and we instantiate a new post number exception with the message positive and followed by space. That's the space right there. We have for loop. For I equals 0, I less than numbers.length, so this is a normal. We're looping through the entire numbers array. And then we are trying some potentially dangerous code. We are trying the potentially dangerous code, and then we're catching. We have 2 catches. So the first one we're catching, we're filtering out, we're just catching this specific exception. And if that exception is not of that type, we then try and get this specific exception. So let's go through the code. So we're saying the try statement. We're saying if integer.parseInt of our current number, if it's greater than 0, throw problem, which will throw the post number exception. And if we don't throw it, then we'll be able to execute the second line and print negative followed by space. So let's go through each number. So we start off with 57. All right, integer.parseInt of 57 is valid because 57 is a valid number. Java knows how to convert that to an integer. So we get int 57, which is greater than 0, so we're going to throw problem. We'll immediately go to the correct catch, which is our post number exception, because problem is of type post number exception. And we print out e.getMessage, which we get the message that we created when we instantiate the object. So we'll print out positive. And I'm just going to track our output on the bottom here. All right, so let's run it. All right, I becomes 1. We'll now look at 50. If I can write out properly. 50. Integer.parseInt of 50 won't work because Java doesn't know how to convert the word 50 into an actual integer. So .parseInt throws a number format exception if it cannot parse the int. So we will, because of this line right here, this statement, we will jump to this catch. And then we print out the string none. I becomes 2, and we will use negative 50. We parse that. Again, Java can parse that. It's a valid number. We get int negative 50, which is not greater than 0, so we'll print out negative. Right. I becomes 3. We get 39. Java can parse that. So we'll throw a problem, and we'll get positive. Alright, so then we get B as our answer. Okay, show the output of the following code. Class test 5, we get our nice static void main. We have two arrays, x and y, both integer arrays of 3 numbers. We invoke mod arrays. Alright, so we pass. This is an important one. This is references once again. We saw this in the past. This should look familiar. We saw this on the last practices. So what I want to do, we have this array, and we have 3, 2, 3. We have x, y, so x. Right, and what we do is we invoke mod arrays with the element at x index 0, which is 1. So A is 1, and then B, notice B is a array, so B is an object. So we know we're going to get a reference, and that's the important part of this problem. We pass in y. What is y? Y is a reference to the array 3, 2, 3. So B then becomes a reference to 3, 2, 3. So what we do now in mod array, we're looping through every element of B, and we're setting bi plus or equals to a. So this is the same as bi equals bi plus a. So what we'll do is we'll loop through each element and we'll add a, which is 1. So what's going to happen is we're going to get 3 plus 1 is 4, 2 plus 1 is 3, 3 plus 1 is 4. So we get 4, 3, 4. And I'm changing what we are referencing, not some different object stored in B. We get 4, 3, 4. And we set A equal to index at 2. So A then becomes, and this is not really important, but A becomes 4. This indentation is a little annoying. The for loop does not have squiggly braces. So there's only one line in that for loop, and that's the b sub I plus equals a. Not the a equals b at index 2. That's why I added 1 to each element and not a different number. The a happens after the for loop, and then we change the a and we return. That return void, that method is over. So we go back up to our main method and we'll print out x index 0 and y index 0. So x index 0 is 1, y index 0 is 4, right? Right here and right here. So I'm going to print out 1, 4, and we get E, none of the above. Moving on. Ooh, recursion. Alright. So we're giving a recursive function rows as recursive because we're calling rows within itself. We invoke it with a 4, so n equals 4, and then let's trace it. So everyone's going to trace recursion differently. I'll do it how I do it, but it's very important that you do trace it. Don't try and come in here and think that you can do it. I mean, you may be able to do it without tracing, that's great, but I recommend always tracing because you're just gonna, be in a rush on an exam, be a little stressed out, you may make silly mistakes. So make sure you trace it. So I'm going to say is rows 4 and we are doing I'm going to flip it. So we have n. So yeah, 4 is not less than 0. So we're going to do rows n minus 1 times n. I'm going to flip it. I'm going to do n times rows 3. Just kind of trace down. So we call rows again. Then equals 3. 3 not less than 0. So we're going to do 3 times rows 2. Let me just kind of follow the pattern. One, then we have 1 times rows 0. Right, and what happens, we kind of go back up. So rows 0, n is less than or equal to 0, returns 1. So this becomes 1. 1 times 1 is 1. So that line returns 1. So back up the line, this is 1. 2 times 1 is 2. So this rows returns 2. 3 times 2, 6. This rows returns 6. 6 times 4, 24. This rows returns 24. We're back at the top of the call stack. So the answer is 24. I'll break it down again. So we invoke rows 4 or rows with 4. And when we go, we don't do the base case. This is our base case. We don't do the base case because we're not less than or equal to 0. So we're doing rows or returning rows times n minus 1. Or rows n minus 1 times n. I flipped it just for me to trace it easier. So we have n times rows of 3 because n minus 1 is, or 4 minus 1 is 3. Whenever this returns, that's what our rows of 4 returns. But in order to find this value, I needed to calculate rows of 3. So that's what I did here. Rows of 3 is just 3 times rows of 2. So I traced it all the way down until I got to my base case. Rows of 0 is just 1. I don't have any more rows to compute to find rows of 0. And then I just go back up my stack. And if this returns 1, this is just 1. 1 times 2. This statement returns 2. Then this is just 2. 2 times 3. And I go right back up to the stack to get to the top. That's how I trace it. If you've seen other professors or other YouTube videos trace it differently, whatever works for you, use that. This is just how I do it. When it comes to recursion, a lot of students get a little tricked up. It's a very important computer science concept. You get it just by doing it a lot and practicing. Because it's an interesting way of thinking. All right, number 7. Choose the correct output for the following code fragment. Alright, so we have an integer array of 101, and we're trying some dangerous code, and we're filtering out arithmetic exception and rate and accepted bound exception. Okay. So we'll try our for loop. So we enter the try statement. We then enter this for statement where I equals 0, I is less than or right at length. And we're printing out 1 divided by array at index I. Okay. So when I equals 0, we print out 1 divided by 1. Alright, because index 0 is 1. So we print 1 base. I equals 1. It's when divided by 0, because index 1 is 0. Can't do that. You cannot divide by 0. Java will throw an arithmetic exception. Because have you ever heard of the n divided by 0 or o divided by k? We cannot divide a number by 0. So we print out 0. Now it's important. When we execute this line, divide by 0, we throw the exception. So we jump here. When to execute that catch statement or that catch block of code, you continue to go down through the line, or down the line of code from there. So we don't need this catch statement, so we would then execute whatever code comes after. But because there's no code, we assume it's over. So we're done. A lot of students get tripped up with this. They think they should go back into the for loop and keep going. You do not. Because this for loop is inside the try statement, whenever you get any exception you immediately jump to the catch statements. Or if you don't have the right catch statement, the program will terminate. So that's why we only get 1 space 0 as the output. If, let's say, the try statement was inside the for loop, then go back up. Right here. The try statement here is inside the for loop. So you would try whatever code. If you jump to an exception, you would handle it, then you would jump to the end where there may be some more line of code. There's no more code, so then Java realizes, okay, we're in a for loop, so let's go back up, increment, check the Boolean, run it again. I'll show that again. We enter the for loop, we then enter the try statement, we try our dangerous code. If we get an exception, we jump to the catch statement, we then execute the catch statement, then we jump to the end, right after that try catch block ended, execute any more code if there's any. There's none, so Java says, okay, yeah, we're still in the for loop by this brace. We just then are going to try to run another iteration of the loop. So we increment, condition, run the loop again, or end the loop. Down here, not too far, we enter the try statement, then enter the loop. We run iteration of the loop, we get an exception, we jump down to the catch statement, execute the catch statement, then jump to the end and execute some code. There's no for loop to warrant me to go back up into the try again. So I'm done. So I get 1 space 0. A. Okay. All right. Number 8. Abstract methods are used when defining derived classes, classes that have no constructors, arrays, interfaces, and none of the above. It will be interfaces. This is one of those tricky theoretical questions. C is obviously a no-brainer. We don't use methods and arrays. Classes that have no constructors, they just use the default constructor. So every class technically has a constructor, it's just the default with no parameters. Derived classes, you don't need abstract methods to define derived classes. If you go back to the first example, C2 derives from C1. You don't need to have an abstract method in here to define C2. And an interface is just a bunch of methods that have no bodies. You don't use the abstract keyword. You can, you don't have to when defining those methods, but every method in an interface doesn't have a body, and that is what that's what makes an abstract method abstract. It's a method that has no body. So all the methods you have in an interface are abstract. Okay. Number 9. Give the following code. What is the output? So we're given public class animal, which seems to be the most subclass. We have a method get color, which returns just color. We're given public class cat, which is a subclass of animal, extends animal, and we override the get color and have it return black. And we have public class dog, extends animal, so it's a subclass or child of animal, overrides the method get color and returns white. And we're giving a driver class or driver program called class inherit, where public static void main method and another void called try me. Try me takes in an animal parameter and it prints the color of that animal followed by the space using a.get color plus and concatenating space with it. In our main method, we are creating a new animal. So this is polymorphism, right? This line right here. I am defining or declaring A to be a variable of type animal, right? But I'm saying it equal to a new instance of dog. And this is the is-a relationship. Dog is a animal because it extends animal. So that is valid. Then we do try me A. We're passing A as an animal. So the compiler, like, okay, this all works because dog is an animal. I can pass that in as a parameter. It has a method get color. Now, when we're during runtime, when this code's executed, it's going to use the method of dog, not animal. So I'm doing new dog. Yes, the type is animal, but it holds a dog object. So it's going to use the dog.get color. So it's going to print white. And then I redeclare A to be a new cat. Again, this is valid because cat is a animal. And I'll pass that to try me. And again, at runtime, we'll use the cat method and return black. So polymorphism is basically a trick to have the compiler say, okay, everything's good. Compiler knows that the methods all exist. And then at runtime, that's when, when your code is being executed, it will use the specific method of whatever object is in that variable. So first it's a dog, so we use dog get color. Then it's a cat, so we use the cat get color. So we'll get white black, we'll get, the answer should be D. Yes, the answer is D. Okay, the following method, I think it's not a typo. The following method intends to be a recursive method. What is the problem with it? So let's look at it. Alright, so we get n, result equals 1. Excuse me. Result equals 1, rec equals 2. If n is less than 2, would result equals n minus 1 times rec. Okay, it looks a little confusing, but actually quite simple. For a recursive method to be recursive, you need to call itself within its body. So we have recurse. I don't see recurse being used anywhere in the body. So how can it be recursive? Method does not call itself. And there you go. Don't even need to dissect what's happening in the code. No matter what parameters we have, no matter what the specs are, it's never going to be recursive because it's not calling itself again. It's going to execute once and be done. And that's why that is the problem with it. It does not call itself. Okay, so that is the multiple choice. We have 2 open-ended, so let's start tackling these. Let's transition here. Okay. Let me pull it up on my end. Question 11. On the exam, you guys would just write the method. I obviously am in JGraphs, so I'm gonna write a little class. All right, so we want to write a recursive method called recprod. Let me redo this so you guys can see. I'm curious, OBS is an interesting platform. Can I change this so you can see everything? Alright, let's hope that doesn't mess up the entire video. Okay, we are doing question 11, write a recursive method called recprod that takes in 2 parameters, array and count. Alright, so public, okay, returns the product of count array entries. So I'm gonna use static. If you do this in the exam, doesn't matter if you do or not, you shouldn't lose points because they aren't asking you to write in a class or anything. It's gonna be an integer array. No, it would not be array. It returns the product. So that'll be an integer. It returns the product of count array entries. So we're going to be multiplying array entries together. Okay, and name is a recprod. First parameter. Non-empty array of integers. I'm not going to use that. We have int count. Okay, so thinking recursively. So we wanted to find the product of count array entries. So we're taking the count, or I'm gonna say n entries in an array, and we are multiplying them together and finding the product of all of them. So we take 1, 2, 3, and 4, we get 4 times 3, 12. 12 times 2 is 24, times 1 is 24. So that's the goal is recursively. We're giving it our array of numbers and count, which is our how many we want to multiply together. So what is our base case? So we want to, when we're thinking about the base case, we want to take a larger problem and break it into pieces. We want to figure out how we can make it into a smaller problem. So we have 1 times 2 times 3 times 4. This is a large problem. This is four things I have to do. But what if, I want to do 4 times, or 1 times, and hand the rest off to somebody else? I've now made it a simpler problem. I'm doing one piece. It's saying, okay, you guys calculate the rest of it. I'm saying, okay, person 1 is, I'm taking 1, and I'm saying, okay, somebody else do that part. And then the next person, like, well, I also don't want to do the entire problem. I want to make it nice and small to myself. So I say, okay, I'm going to only do 2, and I'm going to have somebody else do the rest of it. And then the third person, like, okay, well, if you guys are all going to be lazy, I'm going to be lazy. I'm just going to take 3. Now have somebody else do 4. But if you notice here, we're only down to 1 element. Or even further, we can say 4 times 1, because anything times 1 is the same. So we get to a final 4 times 1, and this 1 represents I have nothing left to do. That's the hint. So if you look here, there's a pattern. We start with a big problem and do 1 times group, 1 times 2 times group. This is a recursive pattern. Again, this 1 represents I have nothing left. So if I have nothing left, or count is 0, there's nothing to multiply, I'm returning 1. And that represents this part right here. Else, if count is not 1, what can we do here? This is where this comes into play. We want to take one number and multiply it with whatever is left in our sequence. And we can use count to do this. Because like I said here, count is a positive integer less than or equal to the size of array. So we can use it as an index. Array this is going to give us the index of the last number we want to count in our array. So I'm giving count 4. Count minus 1 is 3. 0, 1, 2, 3. That gives us 4. That's the last number we care about in our sequence to multiply. So we're kind of going to have to flip our thing. So instead of writing it like this, I can say it's the same as 1 times 2 times 3 times 4. I'm just kind of flipping around how we did it. So I pull out the 4. I want to then give my group to the rest of the people. And to kind of make somebody else do all the rest of the work for me, that's our recursive call. I want somebody else to do the same thing. I want them to do the rec prod of the same array. However, I already did one of the numbers, so I'm going to give them one less to do. and then we can return this value. And this is your the recursive problem. So if I were to go and do a little tracing here, where we have our array and 4, we're gonna get 4 times rec prod 3, 4 times rec prod 3 is just 3, that's what it's going to return, times 2. That's going to give us 4 times 3 times 2. What's rec prod of 2? Times prod of 1. We'll just make sure void make sure I didn't mess this up. I have syntax errors somewhere. Alright, I'm gonna delete this as I can see. Again, on the exam, if you guys there we go. If you guys miss some syntax here and there, you're not going to lose a ton of points unless you miss every single semicolon or every single method call. You forget the parentheses, you may lose some points. But if you get something here and there, don't worry about it because we understand that you're coding on a canvas text window. As we can see here, we get 24. If I make this 5, we get 120. Looking at the answer key, they did it slightly differently, and I just want to explain what they did here. So I did this way. You can also do it a slightly different way, where instead of going all the way to the very, very end and we're just returning 1, you can just say, okay, count is 1. I'm just going to return the last index. So 0, or you can do they count 1 as 1, and this is just 0. That is what they have in the answer key. Instead of going one step further like I did and returning 1, just okay, before we get to the very end, we know that the last count equals 1, right? We're looking at the 1 in the array. We can just return that. So either one works. You get credit for either or. This is the way that my logical thinking brought me to, where other people may bring you here. All right, so we got question 12 now. Okay. File new, Java. Let's read it first. Given the student class, call class student with a field final score, private integer. We have a constructor that initializes student with the final score. We have a setter and a getter for final score. Right. That's it. Write only the constructor for a class course that has two attributes. Okay, we're writing only the constructor. Course that has two attributes, SD list and stats. Okay. What I'm going to do though, in comments, I'm just gonna, we have an attribute student list, std list, that's an array of student objects. If you're in an exam, it says write only the constructor. If you still write this, you should not lose points because this is just you keeping track of what you have to account for. And we have stats, which is an array of integers. So that is our instance data. They want us to actually write the constructor. So now, uncommented, I'm going to write a constructor. The constructor takes in an integer parameter named size. Okay, it initializes all the elements of the array to student objects with a final score of a random value between 1 and 100, and populates stats array accordingly. Alright, so let's do this first part. Let's populate our students array. Alright, so before populating, we gotta basically declare it with a value. So we're gonna do SD list equals new student. And this is just me making a new array. So it's that. And then this is going to create an array of null, because we then have to initialize every element of it. So for that, we'll use a for loop. So we want to go through every element. So I'm going to start at 0 and go up to but less than size. Increment that. So standard for loop. We want to create a new student object with a final score value at a random number between 1 and 100. So we'll index where we want to set our new object. So this is equal to new student. And so we have our constructor over here on the left, the final score. So I'm going to use the math.random method. So alone, this gives us a value between 0 and 0.999 repeating inclusive. So I'm going to multiply this by 100 to get us to our whole number range. So that gets us from 0 to 99.99999 inclusive. But we want one from 1 to 100. So I'm going to add 1. However, we have to be careful. This still returns a floating point number. To make sure we eliminate this by casting it. So I'm going to do int, and I'm going to wrap this in parentheses. So this now gives us an integer from 0 to 99 inclusive. Then we add 1 to it, get 1 to 100. That is our students. Now we need to populate the stat array accordingly. So stats is an array of integers containing the frequencies of each A score from an array of students. An A score is greater than 90. Okay. Oh, yeah, that's an array of integers containing the frequencies of each A score from the array of students. Okay. Sometimes you gotta like reread the problem and kind of and think about it. So an A is greater than 90. So an A score will be 91, 92, 93, 94, 95, 96, 97, 98, 99. These are all valid scores for an A. And stats wants to know the frequency of each one of these grades for an A. So let's initialize stats. Is going to be a new integer array of 10 because I have 10 possible scores for an A. We'll do int final score equals, we'll get the final score of our student. Because now in this loop I want to update stats for this new student, for every new student we add. So I'm going to get our final score for usage. And then we want to make sure the final score is actually an A. So final score is greater than 90. I'm not sure if you have to check, but it's just always good to make sure that, you know, it's not over 100. The answer key has this. I'm not sure if an exam or not, you shouldn't lose points for not having it, because technically, because of this, your student should never be greater than 100, but it's always good to just make sure. So if we're actually an A, because we're greater than 90, we're within the range of 90, 100. If we're in this range, then we have an A. So what we need to do now is we need to update stats accordingly. So what I'm going to do is I'm going to basically convert one of these numbers to whatever index in the array they have to be. So let's think about this. If I have 91, this 91 should map to index 0. 92 should map to index 1. 93 should map to index 2. There's a little pattern here. The pattern is, so like 91 minus 1 gives us 90. Then 90 modulo 10 gives us 0. Or 92 minus 1 equals 91. we can type, and then 91 modulo 10 equals 1. So let's make a general formula for this. We have our final score minus 1 modulo 10. And we wrap this in parentheses. So that's our indexing formula. And we're just going to copy this down here. So we can say, okay, stats, the score of an A that we got, and plus plus. We just want to increment it by 1 because we got one of these A's, we'll increment it by 1 to keep track of it. And that is the constructor finished. Alright, so we only need to write the constructor, so that'll be it for question 12. Question 12. And I won't be able to compile it because it's just a constructor. Alright. Do the last one. Question 13. Okay, I see a lot of classes. Alright, so we're at definition of a child class of class figure named line. So we're writing a class named line, which is going to extend the abstract class figure. The line class is defined by 2 points, attributes defined by the point below. The class should also have these members: a constructor that takes in 2-point objects as parameters and to initialize the attributes, getters and setters for the class attributes, and a method equals that returns the true if 2 lines have the same length and false otherwise. Okay, hint, remember to define / redefine any other methods needed in a child class. Alright, so looking at class figure, we have a protected string name of the figure, and then we have an abstract method, important, in perimeter, and then we have a toString. We have our class point, which we have seen before in homework. It's just, an x and y chord, xy point, and then we have a helper method called distance, which we will definitely be using. Alright, so we want to write a class named line, so public class line, and we say we want it to be a child class for an extend figure. Important. If you're extending an abstract class and your new class is not abstract, our class line is not abstract, you must implement any abstract methods. So we have this abstract double perimeter. So I'm going to take that here. I'm not going to complete it yet. I'm just going to put it here so that I know that I have to come back and do this at some point. We'll start by going down the line of our deliverables where we want a constructor. The public line takes in 2 point objects, point P1, point P2. Also, since we are a child class of figure, we have this protected string name here. Let's also make sure that we take care of this. So instead of having a parameter for this in the constructor, I'm going to say I know this is a line. So I'm going to call our super constructor and just give it line. And this line is a figure. The name of this figure is line. And then I'll remember to make our instance data private point 1, private. Alright, so now here I can do point 1 equals P1, point 2 equals P2. And that is our constructor. Getters and setters for class attributes. Right, so we only care about point 1 and point 2. Yes, we have name, we inherit name from figure. We don't need to do a getter and setter for that. We shouldn't have to. You shouldn't have to because you didn't define it in your class, you're only inheriting it. So your superclass should have already done it. However, they don't, and the answer key does do it. So I'm going to say, as long as they say remember to define / redefine any other methods needed in the child class, and they want you to do getter and setters, I'm going to say be on the safe side. Since figure does not do it, you should do it. I don't necessarily agree with that, but the answer key has it. So we'll do a getter for name. Do a setter for name. So I can do name. I can use name here like this because it's protected. I've inherited it. And the choice to have this in line and not figure, it's not a Java concept. You know, it's more of designing your program. The program's still gonna work whether it's in line or in figure. It just comes down to how you want to design your program, and they decided that they want line to declare the setters, which I don't necessarily agree with, but that is what they're asking you to do. So that's name from figure. Now we need to do point 1 and point 2. So do public getter for point 1, get point 1, return point 1. I'll do a setter for point 1. Let me give myself a parameter. Point, new point. Point 1 equals new point. And I'm just going to copy and paste this and do it for our second point. I'll just change it to point 2. Alright, so we have getter and setters for name, point 1 and point 2, so that's done. Then we want a method equals that returns true if two lines have the same length. Okay. Public boolean equals the line, our other line we want to compare to. And let's do that. So in figure we have this abstract double perimeter that says it returns the total length between the vertices in a figure. Well, that's exactly what we're looking for. We're returning for lines that have the same length. Right, and that returns a double, so I can easily just do return the perimeter of this one equals the perimeter of the other one. So if these two numbers for this one and the other are the same or equal, this expression becomes true. If they're different, it becomes false, so we'll return whatever this expression gives us. Now it's nice and easy. If you want to use this keyword here, you can. You don't have to. Right? Then let's implement our actual perimeter method here. So perimeter returns the length between two vertices. Our vertices are 0.1 and 0.2. In class point, we have the method distance, which gives us the distance between the current point and the other point. So let's just use that method. We have return 0.1 and it's the distance to our other point. Yes, I could, rewrite this entire formula here and use that. That's doing extra work. Use what you got. If they are providing you with methods to use, feel free to use them. Makes your life much easier. So looking at this class, we should be good. It's going to compare with the answer key here. We have our instance data 0.1 and 0.2. We have our constructor with the 2 points, and then as well as calling our super constructor with line. Getter and setter for name. Getter and setter for 0.1 and 0.2. We have our equals method, and we have our perimeter method. And last one, we'll add one more thing here. We want to have a toString method that is specific for this class. Because right now we have a toString in figure that returns figure, but if we're a line, we want more of a descriptive one for this class. So there's no set format for these. Just want to make sure that you give a good amount of information. So I'm going to do line, and I was looking concatenate it with 0.1, because class point has their own toString method, so it will basically put this where 0.1 is, and then I'll also do 0.2. Nice little toString, so we can use some info about this line. Okay, and that is it. No. Yeah, so that'll be it for question 13. I'll be honest, this get and set name I don't think should be necessary. I feel like the design of this was weird and these should have already been given in figure or not needed to be done in line. Again, it's all about design. So there's no like Java concept you need to know to why this was put here. This was only put here because the question was designed that way, the program was designed that way. In more of an industry standard, this would be in figure, it wouldn't be in this class, but they wanted you to put it here, so it was put there. Yeah, that is it then for this final. A little bit longer of a video, which is all good. If you guys have any questions, please feel free to email me or reach out on the Discord. Best of luck with this final and the rest of your finals. I hope you guys have a great summer break after final season.